excited to give this talk. I gave a somewhat similar talk last year for anyone who might have been here. Just out of curiosity, was anyone here in attendance last year at this? Of course, St. Mark was. Okay, yeah. So if you recall, last year I gave a talk on what was it? I believe like Docker Swarm on IaaS. Things have come quite a long ways since then. Today, if I were going into doing spinning up a Docker Swarm on VMs, I would hope someone would come and jump on me and say, no, you should stop right now. There's way easier ways to go about it, way safer ways that you can save a whole lot of time, and that's what leads me to give you a talk about Azure Kubernetes Service. If you are happening to implement a Docker Swarm, if you're implementing a Docker Swarm, stop. If you're implementing Docker Swarm on IaaS or Kubernetes on IaaS, and that's a result of my talk last year, this is my attempt to bring you back. Let me bring you back to the light side here. So, quick blurb about me. That's me. That's how happy I am all the time. I do like to joke quite a bit. I'm a software developer and consultant at Nebula Technology. I am a co-organizer of the Backend Devs Meetup, and I also recently founded, or whatever you want to say, became the primary organizer and started a new community group called Docker, Kubernetes, and Beyond. The intention is to immerse yourself in Kubernetes, Docker, containerization, anything in that ecosystem, in that realm, service meshes, anything you can think of. So that you can learn and build upon other people's experiences. You can share your approach, bounce it off other people in the community who are interested in similar things. So, in this talk, I'm going to kind of give you an outline of what I want to express. I don't want to teach you how to use Kubernetes. I don't want to teach you the inner workings of Kubernetes per se, but I do want to talk to you about why and when you would use Kubernetes. And I also want to talk to you about how AKS, or Azure Kubernetes Service, specifically extends Kubernetes, all the goodies that it gives you on top of using Kubernetes. So we'll start with the what. What is Kubernetes? Kubernetes is an open source system. It's right? What is Kubernetes? Yeah. Kubernetes is an ecosystem or a system that groups together application containers into logical units for the sake of simplified management and discovery of those containers. Service discovery is a big thing that you'll find with Kubernetes. This is big because it overcomes a lot of the limitations that you might find if you're deploying your services, microservices to VMs. If you're doing that, I'm certain that you're going to be experiencing pain points. If you're not already, then you will be very soon. In terms of managing configuration, managing secrets, any other number of things. Especially as you scale, you have to really scale your ops team to manage running services on VMs, right? There's a lot to do with managing those VMs alone, as well as a PaaS solution. There's certainly a tipping point with microservices when you're running on PaaS, secret management, configuration management. It becomes difficult. There's natural limitations, and even the tools that are out there that attempt to solve those pain points with PaaS, they tend to topple over at some point in time fairly early on. So Kubernetes is really great with automating deployments, scaling your services, scaling your infrastructure, and managing your services. And I'm going to use services and applications somewhat synonymously throughout this talk. So now let's talk about the why. Why would you use Kubernetes? You get global scale out of Kubernetes. You can scale without increasing the size of your ops team, as we've already kind of mentioned. Kubernetes will grow with you. As the complexity of your system grows, Kubernetes also becomes more flexible. It's highly extensible. You can write. It's got really great APIs that you can write extensions toward or plugins toward to extend its capabilities and functionalities. So it also customizes with you. I will also stop at this point to just take a moment to say, Kubernetes is, I know it came on the scene relatively recently, within the last, I think it was released, I actually don't know when it was released, 5 years ago or so. What's that? 2011? Okay. Yeah, it's weird that I don't know that. Anyway, so it's a relatively new kid on the block. Not a ton of people have, or a ton of organizations have implemented it in their production systems. So I know that it's relatively daunting to think about, this newer piece of relatively unproven, so to speak, the cool kid tech is coming to our production system. I realize that's scary. What a lot of people don't realize is that Kubernetes is actually the third iteration of its kind. Google started out many, many years ago when they realized that they were having scaling problems and they started building out their microservices. They started out with a system called Borg. I'm sure many of you have at least heard some form or some minimal form of this explanation, but they started out with a system called Borg, and it helped them to begin to scale. They ran into issues with Borg, and they realized that they needed to do some refactoring, some expanding, and it wasn't fitting their needs quite as much anymore. So they did a rewrite. And the rewrite was called Omega. It was all the lessons learned from Borg. Out comes Omega. Same thing happens. They decide to rewrite again. Out comes Kubernetes. All the lessons learned from the prior systems into Kubernetes, and they also happen to share that with the community, obviously. And now, even all the big names are contributing to Kubernetes. Microsoft, I know, is especially all in Kubernetes. They've got plenty of people developing directly on Kubernetes and extending the functionality of Kubernetes with things such as AKS, which we'll dig further into. Kubernetes is really cool because you can run anywhere. This is an Azure talk, so maybe it's not good that I would tell you that it does help you be cloud agnostic. Kubernetes is, you can pick up your Kubernetes cluster, and if you can run it on AKS, you can also, with relatively minimal ease, run it on EKS. You can run it in the cloud as well as on your local infrastructure. If you're running on-prem, if you have whatever dictation or regulation that forces you to run on-prem, no problem. You can run that on-prem. And the cool part is, when you're ready for a cloud transition, you can easily transition to the cloud. The big difference is Kubernetes is the I guess the way I would put it is that Kubernetes is your new infrastructure layer that you're interacting with. When you want to spin up a new app or something, you're not provisioning a new VM to run that application. You're putting it on your Kubernetes cluster. And then you just have to, if you're running on-prem, you have to bridge that gap and add VMs to your cluster if you need to or whatever. But you're not actually adding that, saying I want this application to run on this VM. So we said, yep, run on premises, in cloud, a hybrid. You can span across them. You can have a network mesh that runs across cloud or hybrids, public cloud, private cloud. However the case, if you're worried about Azure going out of business and you want to run on AWS as well, you could do that. You could span between Azure and AWS. I've already mentioned that it's modular and pluggable. You can write custom APIs, simplifies your service management, and minimizes overhead of managing. So another why you would run Kubernetes. This is probably actually a little presumptuous, or I don't know. Maybe it's mean for me to give this title, but I really feel like it's true. As we move forward, your competitors are going to be looking for ways to move faster, ways to scale bigger, ways to handle more traffic, don't fall behind. That's one of the reasons why you want to use Kubernetes. And specifically, if you consider like the migration path or the things that you have to implement for Kubernetes, and this is a very simplified set of things that you need to implement or to think about, but containers are going to give you the ability to focus on what matters by packaging your dependencies together with your application and shipping them out to dev, test, production. So you no longer have to focus on your VMs, figure out what dependencies you need to have where, and then deploy your code. You can build everything all into your container and ship it. So anywhere where you have a container runtime, you can run. So that lets you not focus on keeping servers patched, updated, and sync. You don't have to focus on managing applications. Actually, with Kubernetes, you don't have to focus on managing applications across many servers or PaaS solutions. One note I want to make here. I've mentioned services a lot. Microservices specifically is what I want to call out. But Kubernetes, if you do have monoliths, Kubernetes is not the platform for your monolith. They don't go together. But if you do have monolith, Kubernetes is a great way to begin breaking out your services and deploying. Yeah, absolutely.
So are you suggesting that instead of doing a massive rewrite and boiling the ocean, you take small parts and move them? So can you give us a couple of instances? Like let's say you have a monolithic app, a web app with a database and stuff like that.
So exactly, if you've got a massive monolith, and for the sake of clarifying what I mean by a monolith, I'm saying you've got an application with buy-in from many departments. You want to make a change for marketing, but finance also wants to make a change. Those changes compete. You want to make a change for marketing, but you also have to have buy-in from finance. The overhead becomes really intense in terms of deployments, deploy times, the length of your deploys, or between your deploys. Typically with monoliths, you're going to be looking at weeks, months, longer periods of time. So I think your question was like, how would you go about doing that breakdown?
Yeah.
I would not suggest a total rewrite. I would never, I can't say never, but the general approach would be to do something like discover a bounded context. This is straight out of domain-driven design. If you happen to read the book, if you haven't, I highly recommend it. But discover your bounded context. Discover where you have pieces in your application that you can vertically slice out so that they're not calling out into other pieces of your monolith, if you were to break out another service, don't have it calling into that service. It needs to a service needs to fully own its task. Otherwise, your SLAs, if you don't own your task, and this is going into a whole different talk on microservices, but find those pieces that you can pull out. It can own its task front to back. So, if you've got a user interface, it serves the user interface all the way down to calling into its data store, storing stuff, things like that. Perhaps you can have some async stuff that calls out to increments or whatever the case that you might have. I also have a talk on microservices that goes more in depth with some of this. Maybe if Santosh doesn't want to give his Cosmos one, I can give that talk. Does that? Yeah. Kubernetes.
Just one thing around that. So we are trying something similar in our organization. One of the things that we have to be aware of, right, when we define those API boundaries and try to kind of synchronize all of them, we have to be aware of the ecosystem, right, which tries to consume the data within those API boundaries. And that's where it is going to be much more painful than we can think of, So we have to be cautious, and we are aware that when you look at your API boundary, you might say, okay, I'm taking out a very small piece of it. But when you start trying to decouple all of the dependency
Yeah,
from
yeah.
a monolithic database,
Yeah.
you'll find that, oh, we are trying to boil the whole ocean
Yeah.
rather than the only small piece that we are actually focusing on. So,
Yeah, and so it,
just to be aware of the actual problems,
yeah, absolutely.
monolithic redesign.
It can often lead to major refactors of your monolith
Exactly.
before you even
Mhm.
are able to pull out your services.
Wow.
Yeah, absolutely. But that gives you a great way. I mean, you've already got something running, and as you start to do those refactors, you can play around with the service boundaries
Right.
with your monolith before breaking it out. Because after you break things out into microservices, it's going to be harder to begin stitching things back together or splitting things out differently. It just becomes a lot more difficult.
One of the best way to handle that is define your API boundaries and stood up those API first before you start attacking your data layer, and allow all of the calls, whether read and writes, right, to go through those API and then modernize your
Sure.
data
Yeah.
layer.
Yeah.
So question, we had a talk earlier about, app service plan with apps and, the comparison of the two, and so, web apps are super simple, right?
Uh-huh.
Now with Azure you can scale, you have elasticity, but you don't have a lot of control, right? And so you have that cost benefit, right? Kubernetes, you can configure the heck out of it, but a little bit of a learning curve, a little bit more complicated, but you have super control over it, right? So what would be the sell then if you're doing small to middle project, right? Nothing too big. What's the benefit of not just doing a web app? Because it's not really a microservice, not really a monolith, it's kind of in between, but there is that overhead of Kubernetes. You just have something simple, you do have kind of the elasticity, which is kind of like orchestration, spinning with containers, you have the virtualization and the abstraction, right? You're not dealing with VMs, you're not having to maintain state, you're still stateless. So there be benefits, and my question to you, is there a benefit having really a small to middle tier application? It's not a monolith, not really a microservice, to then use Kubernetes as opposed to just using a web app?
Sure. It's quite possible. I can't give you without knowing a whole lot more specifics, it'd be hard to really give you a great answer, but I certainly don't.
General rule, just general.
Yeah, general rule, I would say start without it. And then as you get to the point that you want to start testing things out, the big advantages that I would point out that you would want to look for are likely going to be cost savings, though I can't guarantee that. That partially depends on how versed you become at configuring your Kubernetes cluster. I'm not going to say that it's difficult to do that, but it all depends on what you're doing, what you're running, and how much scale you want beyond, if you want to anticipate load. Small to medium though, I certainly would hold off on actually making the jump straight to Kubernetes.
That's what I thought. I just wanted to know if you're like, no, there's this reason, and even in small to middle, you would still want to use Kubernetes, and just want to know if you had that viewpoint.
Yeah, it's a decent bite. I mean, you're right. Like there's a significant amount of time involved, and if you're just doing small to medium size, application, it's a lot to buy in just for that. But if it's organization wide, so that's another thing that I would say is when you spin up a Kubernetes cluster, I wouldn't suggest that you spin it up just for that one application. It's not like a web app. You're not going to say, I'm going to spin up this Kubernetes cluster for this application. It's right. You're going to spin it up and possibly use it across your whole organization. I mean, that's a possibility. You could have hundreds, if not thousands, of services running on your cluster.
Probably when you have a large number of applications and you are trying to manage those, and then you're feeling the pain in managing those in web apps, at that point probably you'll start doing it.
Exactly. You start having difficulty managing the configuration, the secrets, things like that across all your services. Deploy times, you waiting on ops and stuff like that becomes difficult. Yeah, absolutely. Oops. So Kubernetes features that I want to point out, and I don't want to take too long on this slide and bore you guys. But there's, regarding the cost, the automatic bin packing, what that determines is okay, Kubernetes says, okay, I have these nodes. Nodes are synonymous with a VM. I have these nodes, and I have all these different services. For each service, you've defined all the resources that will need, compute, memory, and it's going to schedule that onto different VMs, and it's going to pack those VMs as much as it can, but not anymore. And then if it needs new services to spin up to answer to more load, it'll spin them up somewhere else because it knows that it's already maxed out this VM. Self-healing, yes, you have this with a lot of PaaS solutions, but it's here with Kubernetes as well, and it actually goes to new levels because you can define so much deeper the self-healability rules. Secret and config management, I've already alluded to that. Horizontal scaling. And again, all this is configurable. Batch execution actually is a really great use case for Kubernetes, spinning up infrastructure to run batch execution jobs. Automated rollouts and rollbacks. Yeah, again, you can get this with PaaS, but again, Kubernetes goes to a whole new level. You can define how your rollouts happen, how your rollbacks happen. If you happen to want to kill off all your containers or all your service before you spin up a new service, you can do that. If you want to just do one container at a time for each service, spin up a container, make sure it's ready to serve requests, start pointing requests over, kill off the old container, go to the next one, spin it down or spin it up, shut one down, just route your requests. I got that order out, but storage orchestration. You can mount. You can have persistent volume stores. You can mount. You can mount volumes in your services or in your containers. And Kubernetes also has service discovery and load balancing. Service discovery is really cool. Kubernetes has an internal concept of DNS, so it can route requests based on labels, names, things like that. So let's talk about a quick migration path. Already kind of alluded to this as well. I guess the scenario here would be that if you're on-prem or even using PaaS currently, or IaaS, it doesn't matter. The first step is going to be to implement containers. So containerize your applications. Use Docker. Docker's probably going to be your best bet because there's plenty of documentation out there. There's certainly no shortage of community surrounding Docker. And then once you get those applications containerized, or as you get each application containerized, begin running it on a PaaS or a CAS solution. PaaS, we all know what that is. I assume it's platform as a service. It's a web app, something like that. Azure App Services actually have a container option where you can run a container on your app service. CAS is container as a service. There's the Azure Azure
Container instance.
Container instance, thank you. My goodness, why was the word container hard to come up with? The Azure Container Instance, you don't have to manage the app service or anything like that. You hand it a container, it runs it. You don't have to think anything else about it. Essentially, anywhere with a container runtime. If you even wanted to really run on-prem, you could do that. If anywhere you have Docker installed or some OCI compliant runtime.
Quick question. I'm 101 when it comes to this.
Okay.
All right. Is a container analogous with having an operating system, running an operating system?
Yeah, you could think of it that way.
I mean, I'm going back to my mainframe days, like CICS, which was
Sure.
which was a operating system for doing interactive type of activities. But when you used it was an operating system, but it wasn't an operating system that was the host.
Okay, yeah. So the quick way to, let me give you just a quick one on it. When you run a container, it's going to have access to, through the container runtime, access to, I always get this wrong because I just get mixed up. It's going to have access to the hypervisor. It's going to have access to all your OS level. I guess that wouldn't be hypervisor. It has access to the underlying OS.
Okay.
And the big thing is, if you're familiar with C groups and namespaces, that's the separation
Okay.
of both resources and C groups are for resources. Namespaces are. I'm totally blanking out, but that's the big picture.
Mhm.
It's speed too, because it's when you're doing the VM, you know, you have to virtualize the hardware itself. And
Absolutely.
So when they said, hey, that's kind of slow, but you have better security with VMs, but it's beefy, right? And so your
Right.
containers are super lightweight. You still need the underlying platform hardware, but since you're virtualizing the OS, you can spin up containers quick because it's just.
Okay, thank you.
Yeah.
That
Awesome.
clears it up.
Awesome,
Thank you.
great, glad to hear. So this part is going to get you familiar with the first step of just containerizing applications, what the workflow looks like, what your CI/CD pipeline looks like for just building your application and packaging those dependencies with it in the container. Part two, once you have things running in containers, you can begin creating your Kubernetes cluster and migrating some of these containers that you've already created into your Kubernetes cluster. You've already got them running. There's no risk. You can start putting them in here, play around with them, get comfortable with them, push them to production, and when you get comfortable enough with Kubernetes, begin flipping the switch, route some traffic over there, one service at a time. Get familiar. Yeah, and so this will add, all the orchestration goodies and things like that of Kubernetes to what you're currently doing. At that point, once you migrate everything over, all your new applications can just go straight there. You don't have to, by this point, I would assume that you're comfortable with Kubernetes, that since you've migrated everything over, I would hope you are. If you just flip the switch and everything's running in production on Kubernetes and you're not comfortable, dear God, please slow down. But yeah, so at this point, yeah, you're ready to rock. Begin any new apps you build, put them out straight to Kubernetes. This is your new infrastructure layer. That's not totally true, but it is. It's what you're going to be interacting with now, and then you can improve and expand on your cluster, on your monitoring, on anything and everything that you need for your particular use case. So again, I don't want to dig into specifics on Kubernetes except for this. I want to show you, I just want to give you a quick idea of what it's like to spin up a Kubernetes cluster on your own infrastructure. This could even be on, you spin up VMs in Azure and create a Kubernetes cluster. And there's value in doing this, and you'll see why in just a second. I keep looking at you because I have a feeling you know what's coming. First, you're going to need to acquire and configure some VMs, install an operating system, minimum of 4 VMs. That's going to be 3 master nodes, which essentially orchestrate or control your cluster, and at least 1 worker node, which is where your load actually runs, where your services, your applications actually run on that 1 worker node or more. 3 would be, I'm not going to go into that. Once you've done that, verify your MAC addresses don't overlap. Verify that the product UUID also doesn't overlap for those VMs. Configure IP routes, configure ports, install and configure Docker, install and configure Kubernetes runtime, install kubeadm, do this, do this, do this. It's way off the screen by now. Oh, there we are. I'm not excited, and I know you're not. I don't want to, personally, I don't want to go through those steps. That's days and days worth of time setting up a Kubernetes cluster with the absolute bare minimum that you need to get moving with Kubernetes. Absolutely not. Not worth your time, not worth my time. Your time's better spent on maintaining applications, keeping things running. And so you should do that. Not set up a Kubernetes cluster. Instead, this brings us to the Azure Kubernetes Service. And this is where the extensibility of Kubernetes comes in. Azure Kubernetes Service, or AKS for short, they abstract away all the hard stuff. And not only that, they do it for free. There's quite literally no cost involved in the abstractions that they provide.
They being Microsoft Azure?
Yes. The security, the patching, the updating, the configuration of all your VMs, that's all handled. That's all managed by Azure. And you get all those VMs without having to ever touch them. You don't ever have to think about the VMs that lie underneath. Azure Kubernetes Service is simple to deploy. I'll show you how simple in just a minute. As we mentioned, all VMs are managed. VM scaling is automated. And master nodes / VMs, same concept, are free. Kubernetes calls them nodes. We all know them as VMs. Master nodes. So remember I said at least three VMs for your master nodes. That's the least amount that you would want to run in production. Generally, you might have more than that to have fault tolerance. If one master node goes down, 2 is the minimum that is. Let's not go there. It gets complex. That's what I want you to know. It gets really complex knowing what you need to do to be safe with your Kubernetes cluster in production. But fortunately, AKS takes that away from you. They say, we're going to make sure that you have what you need. We're going to make sure it's stable, secure, and they give you that portion for free. And those master nodes, if you were to go and look in your resource group, you're not even going to see those master nodes. You're just going to see your AKS cluster, and there's no cost for that. The AKS cluster is absolutely free. You just pay for the infrastructure that's underneath it for running your workloads. So, let's face it. Keeping the lights on, managing and maintaining servers, backing up and fixing servers. There's no clear value add. This is just preventative maintenance, right? This is just keeping the lights on. This is just making sure things run smoothly and people don't get mad. Making sure your customers can be served. So let that be automated away. Like that's the big takeaway with AKS here. You can buy back time that way for new features, products, and POCs. Here is how you create let me make sure, yeah. This is how you create a Kubernetes cluster. This is the comparison to that slide that went all the way down to here. You just run AZ AKS create -G for resource group, specify the resource group name, -N for name, and the name of your Kubernetes cluster. It's as simple as that. You can go a couple steps further. You could enable add-ons such as Azure monitoring, which will let you monitor your cluster all the way down to the container, down to the process level. It lets you see and view all the resources that are being used, all your nodes, how loaded they are. Again, all the VMs are going to be managed by AKS. Can't emphasize that enough. That's one of the ways that your ops team does not have to scale when your workload does. When the number of requests you start getting increase, you don't have to worry about those extra VMs. Kubernetes can be upgraded with a single command. Say Kubernetes today launches version 13.1, I think, would be the next version that's about to come out. You have a new feature in there that you really want to get into your cluster. That's no problem. It's a single command to update your entire cluster. A couple of extras. I already mentioned the monitoring. Lets you really dig deep. Azure Active Directory integration. There are also other ways that AKS lets you do access control, but this gives you role-based access control for cluster management access. Yeah, and so dev spaces and virtual nodes. Let's dig a little deeper into those actually, because there's some really cool things. If you have, say you have a dev cluster running or a dev service here, you've got several different pieces of your application split into services. Susie down here decides that she needs to make an update to the bikes service. So now she pulls down the code, she starts developing on it locally, she runs it, she can hook right into her cluster. So that when she hits, it's actually going to be, that's for John, but when she hits susie.s.dev.myapp, what she's going to get is she's going to hit this dev bike sharing web, so this web app, and when she does a post or whatever the case from here, it's going to hit her local instance. Instead of running through the full dev workflow, it's going to hit this part of the dev workflow, it's going to route traffic to her instance, and then back up to the rest of the dev workflow. Same thing with John here. He can work on it at the same time, and he's not affected by what changes Susie is currently making. He's working off of this, this path. So it's a really great way to not have to mock your dependencies. You can plug straight into your cluster and run your services and make use of what's already there instead of having to mock those items. So, really great for end-to-end testing. This also lets you, it lets you interactively run and debug inside of your cluster. So the next item from that list that I wanted to talk about was virtual nodes. Virtual nodes go back to, yes?
How do you go about setting up those dev spaces? Is it just you set up a user for that particular app and it's automatic? Or, how much configuration items is there for that?
In Azure, in the Azure portal, you can enable it as just a toggle switch. So you enable it, and then from Visual Studio, you make Visual Studio aware of your AKS cluster, and then it will handle pretty much the rest.
How does it know who you are and what URL to give you?
So when you are in Visual Studio, you would create your own namespace as you're going through the process under the dev spaces. And so from there, what you create, it then fills in because it knows that the parent resource is the dev spaces namespace and AKS. So whatever dev spaces had in it, it will copy that for setup to know what else is there.
And then when you deploy your own containers or your own pods, it knows to go to yours. Okay.
Yep. I pointed to Troy because he was the most recent of us to spin up dev spaces, which is really cool. Okay, so virtual nodes. This is the next one that we wanted to talk about in terms of extras that AKS gives you. And this goes back to the Azure Container Instance, the container as a service that we talked about a little bit earlier. Virtual nodes are a concept that use this ACI or Azure Container Instances for the sake of rapid scaling. You have, suddenly today you post something and you go viral. You suddenly have millions more requests than normal, and you need to serve all those requests instantly. That's what these virtual nodes are for. And the reason why Azure has implemented this is because the VMs that serve as your nodes in your Kubernetes cluster, when you need to scale, say you get a burst of traffic, sometimes you don't have minutes to wait for those VMs. This is certainly a lot better than if you're on-prem and you're having to provision those VMs or have a bunch on standby that aren't doing you any good. But sometimes you just can't wait minutes for a VM to spin up and begin scheduling containers and running your applications. So that's what ACI is for. What will happen is ACI will take that, it'll spin up in sub-seconds, maybe a few seconds to spin up your container, and it will instantly start handling that load, and then AKS will spin up a node or as many nodes as it needs, begin to schedule containers there to take down the number of virtual nodes that it's using. These virtual nodes are not cheap, so you definitely want to not use them as much as you can, but they're really great for protecting you from outages as a result of spikes in traffic. As I said, yep. On-prem, if you're scheduling those VMs or building those VMs, it's going to take hours to days. AKS takes minutes. ACI is sub-seconds. Now this is cool. This takes it even a step further, because if you're running on-prem, you define that you need a load balancer for a service. You also are responsible for that load balancer. You have to configure that load balancer, hook it into your Kubernetes cluster. That's obviously a heck of a lot more work. So what do? Kubernetes has a concept here. I'm not sure, is that big enough for everybody to see okay? The big idea here is that I'm going to apply this file to my Kubernetes cluster. This is a service definition. So I'm saying I want a load balancer. And the configuration for that load balancer, I want to watch on, for protocol of TCP, I want to watch on port 80, and I want to route traffic from port 80 to the target port of 8080. And so where's that going? It almost kind of here, it doesn't look like I've specified where that traffic's going, other than to say app is app name. But that's where I mentioned Kubernetes having the internal DNS. That's what's happening here. I'm specifying this label, and I've specified that label for my actual deployment or for my application. And so Kubernetes already knows what to do with that. And it'll actually create a load balancer in Azure, configure it to route traffic to this application. Quick recap. Start with containers, then move to orchestration when you feel the pain points. Additionally, Kubernetes, as we have pointed out, is packed with all kinds of goodies, but it's hard to set up, and it's notoriously hard to manage in production. Fortunately, AKS takes away the difficulty of that, and it does so for free for that matter. And it comes loaded with all kinds of additional goodies. You're going to need a larger gift bag. Thank you. So what next? I mentioned that I started a new meetup, and that this is the intention of the meetup, is that if you do have more questions, you want to know more, or you want to validate an approach to shift toward Kubernetes, this meetup is intended for that. Additionally, feel free to reach out to me on LinkedIn or Twitter. I'd be happy to answer questions or talk about this stuff. I live and breathe this stuff. Yeah.
Does AKS provide flexibility to add worker node in your on-prem?
Oh, that's a good question.
Can you repeat the question?
Yeah, the question is, these virtual nodes that allow you to respond to rapid bursts of traffic or rapid scaling needs, can you use or leverage that for your on-prem Kubernetes cluster?
No, sorry. My question was, when you create a cluster, you need to define the worker nodes in the Azure. Can we additionally include worker nodes from our on-prem VMs, so that means we kind of have a hybrid solution with some machines are our data sensors?
Sure, to have resources standing by essentially for. So the way that I would do that would be to have additional nodes stood up far beyond, what you think you're going to need to scale to. Because am I still missing?
And means it's not for scaling, but if you want, means let's suppose I have some infrastructure in my premises, but we want to increase a little bit, so we can create some nodes in the Azure. We don't want to purchase additional hardware, and as we move forward, as we grow, we will be adding additional nodes in the Azure, but we still will be utilizing the existing infrastructure.
You're talking about hybrid?
Yes.
Okay.
Yeah, so I see what you're saying now. Yeah, the way you would begin to leverage a hybrid approach would be to use a service mesh, something like I believe Istio or HashiCorp has a product called Console that allow you to make that service mesh so that you could have essentially one cluster and route traffic between those. You might additionally consider something, that might not be the best approach for you because there is additional overhead even for that and understanding how to best leverage that and not shoot yourself in the foot. So there might even be an approach of have two separate clusters that you're managing as you're shifting to the cloud, have a load balancer in front of the services that, can balance between them, send 80% to the cloud, 20% on-prem or something, So there's going to be some solution that is out there, and it's going to be very dependent on other factors well beyond just, the hyper-localized. So if you want to talk after this about your specific scenario, I'd love to talk about it. Again, here's the link for the meetup, and if you want the slides for this, it's bit.ly/AKS talk. If you hit the question mark, if you type question mark on the page, it'll give you a link or show you how to use the controls for my slides and speaker notes and things like that. So with that, any other questions or?
All right, thank you.
Thank you very much.